This is going to be our second lecture of Module 2. In this lecture, we're going to be going over general grounding requirements in Article 250. This is also where we're going to be spending the rest of our lectures for this module is in Article 250 as well. We're going to be dividing that up across a couple different lectures, however, as Article 250 is one of the longest and most complicated articles in the NEC. Our objectives for this lecture, we're going to be identifying the NEC requirements for general system grounding, identify systems that are required to be grounded versus systems that are not, list requirements grounded and ungrounded systems, locate requirements for additional grounding not located in Article 250, and our definitions. Ground, which is the earth. I include this one even though it's a very simple definition just because a lot of people don't really understand when we talk about the ground in terms of the code. We are actually just talking about dirt, earth, grounded or grounding, connected or connecting to ground or to a conductive body that extends the ground connection. In other words, when we're talking about grounding something or that we have grounded something, we are saying that we have connected whatever we're grounding to the dirt. I'm going to be placing a lot of emphasis throughout our studies of Article 250 on the definitions of terms and the way terms should be used, because I often run into a lot of confusion on different words and what they actually mean. So I will be stressing that a lot throughout the course of these lectures. And dedicated, this is kind of a repeat of a definition from when we went over in Module 1 when we talked about dedicated spaces. Starting off here at Article 250, Article 250 covers grounding and bonding. To point out again our definitions, these are two separate things. We'll be talking about bonding in a different lecture. Article 250 covers the general grounding and bonding requirements for electrical installations and the following specific requirements. So in other words, we have general requirements for electrical installations, and Article 250 also includes a couple specific requirements, which are the following: systems and equipment permitted to not be grounded, conductors required to be grounded in a grounded system, location of grounding connections, and acceptable methods of grounding and bonding, as well as conditions where grounding may be a substitution for guards or insulation. Most of those were pretty self-explanatory. So once again, we have our general requirements, and then we have this list of specific requirements that Article 250 also talks about. Diving right in here, we're going to be taking a look at grounded systems. Now, based on our definition of grounded, which is connected to the earth, a grounded system would basically be defined as a system in which we have a conductor in that system that is connected to earth, or a grounded conductor, which we talked about in our previous lecture. 250.4A1 through 5 identify what grounding and bonding of electrical systems are required to accomplish. In other words, when we ground or bond an electrical system, we want to do some specific things. There are some specific reasons that we ground and bond an electrical system, and those are very clearly defined in these articles here. A1, systems must be connected to earth in a manner that limits voltage from lightning, line surges, or contact with higher voltage lines. In other words, we don't want to expose the system to more voltage than it's intended to handle. A2 through 4, so we had A1, now we've kind of grouped 2 through 4 into one point because they all basically go over some of the same concepts. Normally, non-current carrying conductive materials must be grounded or bonded together and connected to the electrical source. In other words, if we have some type of material in the electrical system that could be current carrying, in other words, has the potential to carry current, which would be anything conductive, essentially, we have to have all that grounded and bonded together and then connected to the electrical source. And then A5, electrical equipment must be installed to create a low impedance circuit, a ground fault current path, in order to operate overcurrent protective equipment. The earth cannot be considered an effective ground fault current path. A5, in my opinion, is the most important reason that we ground and bond. It's actually the reason that we ground and bond, and then A1 and A2 through 4 are measures that, if we meet them, allow A5 to operate efficiently. Which, in other words, A5, the purpose of A5 is essentially if we have a ground fault somewhere in our system. If you don't know what a ground fault is, it essentially means when current makes contact with something that is a grounded object, whether it be a metal enclosure or a grounded conductor or an equipment grounding conductor. Anything in the system, essentially, it's not intended to make contact with. It trips a breaker or blows a fuse. It opens some type of overcurrent protective device, and that prevents people and property from being damaged as a result of that situation. Taking a look now at Table 250.3. Table 250.3 lists other articles that contain specific requirements for grounding and bonding that modify or add to the requirements of Article 250. So as we talked about on our first slide, Article 250 just goes over the general grounding and bonding requirements for electrical installations, and it has some specific installations, but there are grounding and bonding requirements that are not included in Article 250. Mainly, these are going to be for specific types of equipment, or especially in specific occupancies. For an example, hospitals have a lot of grounding and bonding requirements beyond the scope of Article 250. So if you're working in one of those specific areas or on a specific piece of equipment, you can use Article 250 or Table 250.3 to find those specific requirements. Looking at Table 250.3 here works in a very straightforward way. So for example, if we were working on a cable tray system and we wanted to know the specific grounding and bonding requirements for cable tray, we would find cable tray on our left-hand column, and we would go straight across to our article number. So it's going to be located in our middle column in Article 392, and it's specifically in Section 392.60. Another example of this would be for mobile homes and mobile home parks. If we go down on our right-hand side, we see it's covered in Article 550, and they don't provide us with a specific section for that. It's just included in throughout Article 550. Now, not every occupancy or every type of piece of equipment will have specific grounding and bonding requirements, but if they do, it should be listed in this table. So now we're going to be taking a look at the connection of grounding and bonding equipment. In other words, how are we going to connect to it, or how are we required to connect to it? Grounding and bonding conductors must be connected by one or more of the following methods. And it's very important to keep in mind this is a general requirement for all grounding and bonding conductors. So it doesn't matter what kind of conductor we're using, it has to be connected by one of the following methods: a listed pressure connector or connectors, terminal bars, exothermic, or as it's commonly called, CAD welding, machine or thread forming screws that use two or more threads or a nut, connections or other means that are listed or part of a listed assembly. So we have some general items up here essentially, which are our pressure connectors or terminal bars, typical things, but then we do have this kind of caveat line down here of if it's listed or part of a listed assembly, and it's listed in the sense of you can use this for connection of a grounding conductor, then we can use it. But it has to be listed for that purpose. And paint or other non-conductive surfaces must be removed before connecting to equipment. Obviously, this is because paint acts as an insulator. If we make a connection to a painted surface with the paint still there, we're not actually going to be establishing a conductive path to what we're trying to connect to. Now, moving on, that covers Part 1 of Article 250, which is just your general information. Part 2 is going to be taking a look at system grounding. This is going to be starting on page 106 of your 2017 NEC. AC or alternating current systems must be grounded as specified in 250.20 A through D. In other words, all AC systems we install, it doesn't matter if it's a residential application operating at 120, 240 volt, doesn't matter if it's an industrial application operating at over 1,000 volts. If it's an AC system, it has to meet 250.20 A through D. Part A covers AC systems operating at less than 50 volts. Part B covers AC systems operating at 50 to 1,000 volts. Part C covers AC systems operating at over 1,000 volts. And Part D covers impedance grounded neutral systems. We're going to be taking a look at ABC. Part D is a little bit beyond the scope of this course. We're not going to be talking about impedance grounded neutral systems. They're very rare. You often won't run into them. And if you learn, as with other things I've mentioned in the course, if you understand the general requirements for A through C, if you do have to learn D, it's pretty self-explanatory at that point. Taking a look at A here, which is going to be our AC systems less than 50 volts, they must be grounded under any of the following conditions. In other words, if any of these following conditions exist in an AC system less than 50 volts, we have to ground that system. We're supplied by transformers, and the transformer supply exceeds 150 volts to ground. In other words, we know a transformer has a primary and a secondary. If off the secondary of the transformer we're operating at are less than 50 volts, but the primary of that transformer exceeds 150 volts to ground, then we have to ground our less than 50 volt secondary for the transformer. We're supplied by transformers, and the transformer supply is ungrounded, so once again, the primary of the transformer, even if the primary of the transformer is less than 150 volts to ground, if it's not grounded on the primary, we still have to ground our secondary under 50 volt system. And we're installed outside as overhead conductors. So regardless of the transformer situation, whether there is one or not, if it's installed outside as an overhead conductor, we have to ground it. Looking at AC systems 50 volts to 1,000 volts now, for supply premise wiring or premise wiring systems, they must be grounded under any of the following conditions. So once again, we have a list of conditions. If we hit any of those conditions, we have to ground our system. Where the system can be grounded so that the voltage is not over 150 volts to ground. In other words, if we look at it from a theoretical standpoint and say, well, if a ground existed, it would limit the voltage to 150 volts, being not over 150 volts to ground, then we would have to ground it in that situation. Where the system is three-phase, four-wire, and the neutral is used as a circuit conductor, so this would be in the situation of a kind of an old-school delta system. We have a picture coming up. I'll explain that a little bit more detail then. And where the system is three-phase, four-wire delta, and the midpoint of one phase is used as a circuit conductor. So I kind of got those points flipped a little bit there. Our second point would actually be for a Y system. And then our third bullet point here would be that delta system. And like I said, we have a little picture explaining that. So the star on the left is our second bullet point, where it's talking about if the fourth conductor is used as a grounded conductor. You can see this center tap off the Y, that's our neutral. And for a delta, you can't see it on this representation, but what will commonly be done with delta systems, you don't really see them much anymore, they're kind of an older thing. But on one of these windings, whether it be the RY or B winding, you'll have a center tap in that winding that'll split it, and you'll come off of that to use as your grounded conductor. If you do that with a delta, then you have to ground the system. Sticking with AC systems 50 volt to 1,000 volt, we do have some systems that are not required to be grounded. Now we have three different categories of systems in terms of grounding for 50 to 1,000 volt. I don't want you to get confused. We talked about systems that are required to be grounded. Now we have systems that are not required to be grounded. In other words, for this, not required, if we think back to our optional, our permissive and mandatory rules that we talked about in Module 1, this means we have the option to ground them. It doesn't mean we can't ground them. It doesn't mean that we have to ground them. We can choose. We can either not ground it or we can ground it. Now, after this, we will be talking about systems that are not to be grounded. That means we cannot ground those systems. But just keep in mind, these ones, we have the option to. We can choose. The following systems may be grounded, but are not required to be. Once again, stressing that point, we have the option with these systems. Systems used solely for electric furnaces. Separately derived system used solely for rectifiers that supply adjustable speed drives. And separately derived systems supplied by transformers with over 1,000 volt primary under the conditions of 250.21a 3a through c. So you may have noticed all those are very specific installations, essentially. This isn't something you probably run into every day. It's not a very common installation scenario. But if you do have them, you have the option to ground them or not. And other systems not required to be grounded in accordance with 250.20b. So once again, these are typically very situational and specific, but they do exist. Now we have specific circuits that are not to be grounded. So notice, though, we changed our verbiage from system to circuit. So these are individual circuits of a system that we do not ground. The following circuits are not to be grounded. Circuits for electrical cranes per 503.155. Circuits in healthcare facilities per 517.61 and 517.160. Circuits for or with electrolytic cell line zones per Article 668. Secondary circuits of lighting systems per 411.6a and 680.23a2. And Class 2 load side circuits for suspended ceiling low voltage power grid distribution systems per 393.60b. And once again, kind of our same deal as these systems where we have the option of grounding them or not. These are extremely specific installations. Typically, the way I describe these, though, is a bit of a way to think about the thought behind them, is these are all systems where, in the event of a ground fault, if it were to trip an overcurrent protected device in the system, it would create a situation that could possibly be more hazardous than if that ground fault were allowed to persist, is the reasoning for these. And I won't go very deep into that, and I won't really explain what all these different systems are, since I'm wagering a lot of you may not have ever worked with these specific types of equipments or installations before. But just be aware these are here, and if you do run into them, you cannot ground these items. We're going to be taking a look at service supplied AC systems. So these are AC systems that are supplied by a service. Premise wiring supplied by a grounded service must have a grounding electrode connected to the grounded service conductor at each service per 250.24 A1 through A5. So to kind of break this down, if we have premise wiring that is supplied by a grounded service, so the service from the utility is grounded, we have to install a grounding electrode and connect it to the grounded service conductor at each service, and it has to meet the requirements of 250.24 A1 through A5. Now, you may not know what a grounding electrode is right now. We're going to talk about that. I don't know how much of it we'll get into with this lecture, but throughout this module, we will go into a lot of detail with grounding electrodes and how to connect them to the grounded service conductor. So for those specific requirements, though, of 250.24 A1 through A5, A1 tells us connection must be made at any accessible point from the load end of the service conductors. Where the service transformer is outdoors, one additional grounding connection is required. A3, for dual fed services, a single connection to the tie point is permitted. A4, where the main bonding jumper is a wire or bus bar and connects the equipment grounding conductor bar and the grounded conductor bar, it may be connected to the common bar. In A5, a grounded conductor may not be connected to normally non-current carrying parts of equipment or connected to ground on the load side of the service disconnecting means. So this a lot of information to kind of break down and digest here, or I'm going to try to talk through each of these kind of briefly so this lecture doesn't go on too long, but to give a little bit more detail. So A1, connection, and once again, this connection we're talking about is the connection of the grounding electrode to the grounded service conductor. That's the connection we're talking about. The connection must be made at any accessible point from the load end of the service conductors. So in other words, anywhere from the load of those service conductors that is accessible, we can connect the grounding electrode to the grounded service conductor. A2, we have a specific requirement. If the service is transformers outdoors, we have to do an additional grounding connection. A3, another specific requirement for dual fed services. A4, we run into a term you're probably not familiar with just yet, which is a main bonding jumper. We're going to talk about that in a later lecture once again. This is one of the reasons Article 250 can be a little bit difficult to go through and a little bit difficult to learn, is that you have to bounce around a bit in it. What I usually recommend doing is once we've worked through all these lectures to go back and re-watch them, since as you see here, reference to a main bonding jumper is something in the reading through to Article 250 we haven't encountered yet. So just bear with me, keep this point in mind, and it'll make more sense once we go over a main bonding jumper. But where it's a wire or a bus bar and it connects the equipment grounding bar and the grounded conductor bar, may be connected to a common bar. So that's once again a little bit more specific. And a grounded conductor, so remember we talked about our grounded conductors in our last lecture, may not be connected. Normally non-current carrying mill parts of equipment are connected to ground on the load side of the service disconnecting means. So what this means is, to our A4, kind of what it was talking about a little bit there, what all this achieves is that we're connecting our grounding electrode conductor to our grounded service conductor. In other words, our grounding and grounded conductors are going to be connected at the service disconnect means. A5 tells us anything past that service disconnecting means, we can't connect our grounded conductor to a normally non-current carrying part of equipment or connect it to ground. So in an AC system, there's only one place that we can connect our grounded and grounding conductors together, which is at the service disconnect means. And we are going to go over that main bonding jumper just a little bit right now, real quick. Once again, we'll go into more detail about it in a later lecture. For grounded systems, so once talking about grounded systems here, a bonding jumper must be used to connect the equipment grounding conductor and the service disconnect enclosure to the grounded conductor. Must be done within each disconnect enclosure. So in other words, as I just said, not only we have to have our grounded and our grounding conductors connected, but we also have to have them connected to the service disconnect enclosure itself. So all three of those things should be bonded together. Notice I use the word bonded, as our term here is a bonding jumper. And for listed assemblies with more than one disconnecting means, only one bond is required. In other words, if we have multiple disconnecting means in the same enclosure and it's listed, the instructions state you only need to make that connection at one point and the entire assembly is covered, we only have to do it at one point then. So this is what we're talking about here. So if you have a decent little bit of experience or knowledge in the installation at this point, you'll see where this red arrow is pointing to. We have a terminal bar here, and we can see these white wires would be our grounded conductors. We see these bare copper wires would be our grounding conductors. Those are connected on the same terminal bar, and then off that terminal bar we have this jumper here connecting the back of that bar to the disconnect means. So that tells us that this enclosure we're looking at is the main service disconnect enclosure. This is actually the disconnect for the service to this premise wiring, because we can see our grounded and grounding conductors bonded together, and we have that bonded to our disconnect enclosure as well. Taking a look now at that service equipment grounded conductor that we talked about a little bit before. When AC systems 1,000 volts or less are grounded, the grounded conductor must be routed to each service disconnect means and connected to a common terminal or bus. It must comply with 250.24 C1 through 4. We'll be looking at those next. Essentially, at each service disconnecting means, we have to have our grounded conductor there, and that is essentially for what we talked about before, so that we can bond it with our grounding conductor. And C1 through 4, we'll talk about that a little bit more. C1, the grounded conductor must not be smaller than specified by table 250.102 C1. When the ungrounded conductors are installed in parallel, the grounded conductor must be sized per 250.24 C1, but not smaller than 1 aught. That's a very important note to remember, to keep in the back of your mind. Anytime we're talking about a parallel installation, the smallest we can use for a grounded conductor is going to be a 1 aught conductor. Very important note to remember. And we skip C3 because it's not really a very noteworthy note, but moving to C4, in a 3-phase, 3-wire delta service, we talked about that delta before, the grounded conductor must not have a smaller ampacity than the ungrounded conductors. So they all have to be the same size in terms of their ampacity. And a little bit more on C4 here. A grounding electrode conductor must connect the equipment grounding conductors, service equipment enclosures, and the grounded service conductor to the grounding electrodes. It must be sized per 250.66. So once again, this is almost a repeat of what we talked about a couple times here. Well, we have to have those different components bonded together at that service equipment enclosure point. This is really just multiple different points in this article that we've talked about that really just stress that we have to do that and how we have to do it. Back to our main bonding jumper here. Main bonding and system bonding jumpers must be installed as follows. So we talked about where we have to install it, why we have to install it. Now we're actually talking about how we do install it. Must be made of copper or other corrosion-resistant materials. Where the jumper is a screw only, it must have a green finish. Must be attached in a method complying with 250.8. That was our discussion about connecting grounding conductors. And it must be sized per 250.28 D1 through 3. Not smaller than is shown in table 250.102 C1. Where more than one service enclosure, the conductor must be sized on the largest conductor in the enclosure. And separately derived systems must meet 250.28 D2, or a single conductor may be installed at the source. Now, I think all these were pretty self-explanatory, pretty easy to understand requirements. Once again, these are talking about that main bonding and that system bonding jumper we talked about previously. So that wraps up this lecture. This was our first look at Article 250. Our next session, we're going to be talking about other than service supplied. A lot of what we talked about in this lecture, we're talking about service supplied AC systems. Once again, now we'll be taking a look at those grounding requirements for systems that are not service supplied.